So we're going to prove that the perpendicular from side midpoint bisects the orthic, the side of the orthic triangle. The orthic triangle is just the triangle joining the feet of the altitudes of triangle. It's not as complicated as it sounds. Here's my triangle. I accidentally made that look isosceles, which I don't particularly want. Let me constrain the length of its sides, which is my usual gambit. We're going to want the center of one side. We're going to want the feet of the altitudes to the other two sides. So let's create those altitudes. And as one could now change the color of things in GXWeb, I'm going to make them gray. Here is the side of the orthic triangle. So now what we're wanting to do is drop a perpendicular from D onto that triangle. And what the theorem tells us is that FG should be the same, or the theorem requires us to show that FG is the same as GE. So let's go into our symbolic panel. And notice this result, when you look at it, is symmetric in B and C. This distance is symmetric in B and C. In other words, if you switched B and C around, the result would be the same. This tells us that the theorem's true from the get-go, but we can take a more pedestrian approach and compute the distance of GE. And lo and behold, because really all you've done is swapped B and C in computing this distance, these quantities are the same.